Hey everybody, the number of the day today I think is 30. We're going to go with it, whether it is or not. My two facts go like this. Number one, the minimum age required if you want to be elected to the US Senate is 30 years old. House of Representatives is 25, and the President of the United States must be at least 35, although these days they tend to be about double that age. And then also 30 is the sum of four consecutive numbers, 6 plus 7 plus 8 plus 9, which isn't all that big of a deal, except these four numbers, 6, 7, 8, and 9, were the number of songs on the four sides of the Beatles' White Album. What does that mean, four sides of an album? Well, when this album came out, the White Album, it came out on two records, and each record had an A side and a B side. So you had two records times two sides each, four sides of the album. If that doesn't make sense, you could ask your parents, or if your parents are too young, you might have to ask your grandparents about that one. All right, I'm going to start with this question, and I will finish with the answer to it at the very end of this lesson. But I want you to think about this. Suppose I take a regular 8.5 by 11 sheet of paper. So that's what I've got up here. This rectangle is the sheet of paper, 8.5 inches tall, 11 inches wide. And I want you to imagine that what if I folded it up into a cylinder one way? What if I connected these two red parts together and folded it up so that that red section ends up over here on this side? And then I do the same thing, except instead of folding it, I'll call it folding it horizontally. Maybe I fold it vertically so that this blue side ends up being the vertical part, and the red part is going around the outside. My question is, if I fold it up to make a cylinder that looks like this, that's a little bit shorter, but has a bigger circular base, and then I fold it a different way that has a little taller height and a smaller circle, which of these two will give you a bigger volume? Now again, I'll put the answer at the end of this video. Actually, I'll do a little bit of a demonstration for you. But in the meantime, let's take a look at what we're doing today. We're focusing on cylinders. And so here are the formulas. We found these formulas a few days ago. Volume is the area of the base, pi r squared, times the height of the cylinder. The lateral area is the perimeter of the base, 2 pi r, circumference of the circle, times the height. And then the total surface area is the lateral area plus 2 times the area of the base. So 2 pi r is the perimeter of the base times the height. There's our lateral area. And then this part is 2 times the base. So maybe you memorize this formula as 2 times the lateral area because you want to memorize one formula instead of two formulas. And then this is 2 times the base. For today's exercises, for the things we're going to be doing today, the formulas are key. My tips go like this. Make sure you write down the appropriate formula. If you're doing a volume problem, make sure it's the volume formula. If it's a surface area formula, make sure you use the surface area formula. For step 2, if you skipped part 1, go back and do that. Make sure you've got the formula. Third, make sure you have the formula written down. Obviously, steps 1, 2, and 3, kind of a big deal. Make sure you've got the right formula. Because then the rest of it should be easier. Plug the known values in. If you know the height, plug it in. If you know the volume, plug it in. If you know the radius, plug it in. Plug whatever values you know into the formula, and then finally solve for what you don't. This is where we do algebra. Those of you who like algebra will finally get to show off your algebra skills. All right? And that's going to be true. These 5 steps, well, these 3 steps, I suppose, every single problem that we're going to take a look at today, starting with this one. If the volume, keyword volume, is 4,524 inches cubed, so I'm going to be using the volume formula. The radius is 12. I don't know what the height is, so that's what I'm going to be able to plug in. My formula, volume, pi r squared times height. Make sure you got that formula. Plug in the volume, plug in the radius, and there I've got an equation. This is an equation that I can solve for the height simply by dividing. Divide both sides by pi times 12 squared, as I've done here. We get 4,524 divided by pi times 12 squared. Make sure when you plug this into your calculator that you put this whole thing in parentheses, or plug this part in first and then do 4,524 divided by that. My calculator said it was about 10.000235559. Let's just say that's approximately equal to 10. So there we go. Write down the formula, plug in your values, and then solve for what you are trying to look for. The next problem looks very similar, except I'm looking for the exact radius. We've seen problems like this before. Generally speaking, that just means keep that pi there, leave the pi there, and we hope things cancel out. But I know the volume, I know the height, and that tells me what formula I should use. Volume formula. Volume equals pi r squared times height. And then I plug in what I know. Volume is 1440 pi. I plug that in for volume. Height is 10 inches. I plug that in for the height. And there we go. There's my equation. The only thing that I don't know is the radius. And so we do a little bit of algebra. Divide both sides by pi, divide both sides by 10. Like I've got shown here, all we have left is r squared. And if r squared equals 144, well, the square root of 144 is 12. Now this was an exact answer. The pi divided by pi canceled out. 1440 divided by 10 canceled out. This was exactly 144, and the square root of 144 is exactly 12. This isn't approximately equal to, this is exactly equal to. I've got more examples here than I'm going to go through in the video. I've got 3 more examples, but I would like to actually, well, actually, I've got a few more videos than that, or examples than that, but I would like to make sure that we do a surface area problem because we haven't seen that yet. And then, of course, we have to get back to that problem from the beginning. Let's see, a cylinder has a surface area. There's a key phrase. We know the surface area. We know the radius. And I want to find the height. Well, that tells me I'm using the surface area formula. Surface area is equal to either the perimeter of the base times the height plus 2 times the base, or the lateral area plus 2 times the base, or maybe you just know this formula. Shouldn't make much of a difference because you'll be able to use your formula sheet on the test. So write them all down, have them all ready to go. But then I plug in what I need. 3016, there's my surface area. The radius is 16. I plug that in for the radius. I've got the radius here and I've got the radius there. So make sure you plug it in both spots. But that gives us this big, nasty looking equation here. But it's really not that bad because the only thing we don't know is h. So when I'm simplifying this, I did 2 times pi times 16. Definitely use your calculator for this. I don't know how to do that without a calculator. Well, I guess I could, but it would take a long time. So I just plugged it in a calculator, 100.531. 2 times pi times 16 squared. That also, plug that into your calculator. That gives you a simpler looking equation, some big nasty numbers, but not a bad equation. Something equals something h plus something. So I subtract the thing that I'm adding to both sides to get rid of that part of it. I did this on my calculator too. Something equals something times h. So I divided both sides by that which I was multiplying. So divide by 100.531. That cancels out. All I have left over here on this side is h. And when I plugged this into my calculator, I got really, really close to 14. I forget what it was, but it was like 14.00 something. So I'll round that to 14 millimeters. It's the same process. Use the phrasing of the question to figure out what type of a formula. Plug the values into your formula. I've got the radius is 16, so I plug that in. And then algebra lets us figure out what the missing value is. Okay? As I mentioned, I've got a couple examples that I didn't work through in this video, but you can see my work if you look at the PDF notes. But I also want to take a look at a different type of a question related to the first question that I asked. What would happen if I take a cylinder and I double the height? What would happen to the volume? So I've got a cylinder and then I double the height. This cylinder, the cylinder on the right is twice as tall as the one on the left, but the base is the same. Well, obviously the volume is going to get bigger, but how much bigger is really the question. And then the second question before I answer that is, what if I have a cylinder and instead of doubling the height, I'm going to double the radius. So these two cylinders have the same height, but the radius of the one on the left was doubled to give the radius of the one on the right. Now again, obviously it's going to get bigger. The volume of the one on the right is bigger than the one on the left. But how much bigger? In a vague question like this, I don't have any numbers here. The honest answer of how do I solve this is make up some numbers. Say that the height is your favorite number and the radius is your sister's favorite number. Now, to work this one out, what I did is I just picked a couple of numbers. I chose a radius of 7 and a height of 11, but I could have chosen any numbers in the world. Well, maybe not negatives or 0 or anything like that, but pick a number, any number, and plug it in and see what happens. Well, if the radius is 7 and the height is 11, I get this for my volume, pi times the radius squared times the height. And so what happens from this one to this one, I doubled the height. I went from a height of 11 to 22. And on this one, I went from a radius of 7 to a radius of 14. And I want to see what happens. So I plug it into the same formula. Volume of a cylinder is pi r squared times height. So pi times 7 squared times 11. That's where I got this number from. And if I do that for both of these, pi times the radius squared times height, with my larger height, I get definitely a larger value, but it's not just bigger, it's twice as big. 3,386.6 is twice as big as what it was, so it doubled. And then this volume quadrupled. I doubled the radius from 7 to 14, but I kept the height the same, plugged it into the same formula, and I got this volume, which was 4 times as much as what the previous volume was. And that's a little bit of a hint for the answer to the original question about a piece of paper. So let's take a look at that.
All right, here I have an 8.5 by 11 sheet of paper, 8.5 inches this way, 11 inches this way. And I have made a cylinder out of a piece of paper the same size in 2 different ways. One way, I folded it around like this, so the height is 8.5 inches, and it's got a radius that's a little bigger. And then I took the same size sheet of paper and folded it up like this to make this shape a little bit taller, 11 inches taller, but a smaller circular base. And so the question is, which of these 2 cylinders has a bigger volume? And to determine this, I'm going to fill them with rice and see which one fills more rice. If I could have help from an assistant.
Oh, pick me, Dad.
Come on over.
Oh, wow.
It's my son Luke. Luke's the head of my geometry classes.
Hi, guys.
And we're now going to fill this with rice.
I want to see.
There we go. A little bit spilled on the floor. I'll just have my daughter clean that up later. So, the volume of this cylinder is the amount of rice that I've got in there. And so now, to determine which of these is bigger, I'm going to take this other cylinder that is smaller and put that right there. Now, if this cylinder, the tall cylinder, has a smaller volume, that means it's going to fill this one up to a level that's lower than the other cylinder. If this cylinder has a volume that's larger, that means when I lift this up and let the rice spill out, it's going to overflow. Or maybe, just maybe, the volume of this cylinder is the same as the volume of that one. Come on closer so we can see what happens as we do this. And there we go. The volume of the smaller one is actually quite a bit bigger. The rice, the same rice that filled up the taller cylinder, doesn't come close to filling it up. It turns out to be about a 30%. It's like 29.4% more rice that would fit in the smaller one because, as we saw with the previous example, changing the radius by a little bit has a bigger effect than changing the height, because in the formula the radius is squared, but the height is only accounted for one time. Thank you.